First, I want to share about Abstract. The pipe analysis simulator project aims to simulate fluid dynamics within piping system by allowing users to input parameters such as pipe geometry, fluid density, and the number of pans in the system. Our simulators calculate essential output variables, including Reynolds number, entry length, and head loss. The program employs a systematic approach, organizing inputs and conducting calculation through arrays and functions, ensuring clarity and efficiency in the process. For the purpose of calculation, this program uses 17 equations to determine its corresponding outputs. It is then tested using 10 sets of inputs to achieve the desired result, such as minor loss, head necessary, and many more. The user was asked to input 10 types of variables, ranging from the shape's dimension to the type of pen utilized. Additionally, calculation will perform in Excel to compare these intended outcomes in order to accurately analyze our computation using SWOT. Since the percentage of error value will be so little and negligible, we can conclude that our coding computations are correct and reliable. Nevertheless, our coding encounters several restrictions and dispersion, which will be investigated more deeply in the result and discussion section. The next one is objective. There are two objectives in this programming assignment. The first objective is to use the C++ programming language to construct an analysis program for fluid flow pipes. The second is to determine all parameters needed to solve fluid flow pipes analysis circumstance.
For my part, it's going to present the theoretical background. The first in 3.1 is a list of input. It requires user to enter 13 of inputs that will be used the data to calculate in the equations when the CPU is running. So the first one is a geometry of pipe, which is we have in our piping simulator analysis, we have three types, which is in circular, square, or rectangular. Okay, then we require user to enter the dimensions of circular pipe, density of fluid, velocity of fluid, dynamic viscosity, type of pipe, material used, number of pipe. So this is we have 13 types of input required user to enter. The next one is the list of equations. Because our piping simulator we have three types of pipe, can let the user to choose. One is circular, square, and rectangular. Then the user will enter the diameter. The diameter will use to calculate the Reynolds number from here. Okay, so the Reynolds number from here we can say like if less than the 2,300 is considered as a laminar flow. If more than the 100,000 is turbulent flow. If in between we consider in the transitional flow. And all the data entered and after calculations the coding will automatically detect whether it's in which type of flow. Then which type of flow, such as like turbulent flow, will determine one of the equations that will be used to calculate the head losses. Okay, the next one is fluid flow entry length. This is L. Okay, we'll also calculate by using the Reynolds number based on the data entered by the users. After we know that the flow in which type of, such as like laminar flow or the turbulent flow, the C coding will automatically calculate the friction factor using the equation from the base of what is the flow type. Okay, for laminar we use here, for the turbulent flow we use the Hallan equations. The next one is surface roughness. Because of the Hallan equation required epsilon. Epsilon is the which means is roughness. Because the piping simulator also requires user to choose which type of material want to use, such as like the steel or plastic. So for every different material we have different roughness. The roughness we can refer to the table of Act 2 from the fluid mechanics chapter X. Okay. And the system also, the coding also know which type of roughness material used, because we already entered the roughness data in the codings. The next one is the manual calculation. In the project from here, we need to calculate by manually and to compare the data from in the discussion part, compare the calculation with the coding calculation whether it is accurate, to check the accuracy. Okay, we use the Churchill equations to calculate the friction factors. The next one is the losses coefficients, which means user can choose the bending, how many bending you want that can be calculated, such as if user want to choose two type of bending. Okay, the first one, the bending check which type of bending, like 90 degree smooth bends or the 90 degree muted bend. Okay, the next is the valves. We have the ball valves and the gate valves. If user choose to get valves, three types of gate valves, such as like fully open and the half closed. So all the coefficient from here we can also refer from the table. Then we already enter the data in the coding. So the data will be checked in the coding. Okay, so the next one is the major head losses. You use the LSE wave equations to calculate the major head losses. The next is head losses, minor head losses. You also use the equation that we already put the equation in the coding. Then the next is Bernoulli equations. For Bernoulli equation we have two conditions. One is in the no pumps conditions. The other one is when the flow velocity is constant. So the coding will check whether it's in conditions 1 or in conditions 2. Then the coding will continually run in different conditions. Okay, after the inputs already entered and the CPU is running in the coding, the last is the output. The output will be shown in the screen, which we have the 20 type of different output will be shown. The first entry length, such entry length, the important one for our piping simulator analysis is the major head losses or minor head losses will be calculated using the coding. The next is the methodology. For methodology, we use 4 types of header, and one is include IOStream is to allow input and output operations in C++. For the CMAT is to use in calculations. For the limit function is the header will provide the information about the properties of arithmetic types. The last is IOmanic. IOmanic is the header that allows code to manipulate the output format. Typically we use in the precisions and alignment. For the next is declarations and initializations. So the input methodology used in the program consists of three classes, which are circular, square, and rectangular. Okay, from line 7 until the line 1082, we write the coding in three different classes. After the 1082, just the coding that will be run in calculations, which means the data will be processed and be calculated after the line 1082. So after that, the input methodology involves the systematically collecting the required data. Okay, just now what I say, we have three type input, which is circular, class, square, and rectangular. There are three different spikes that will let the user to choose. The next is for like the after user input for parameters like material types, bulk type, and band orientations, we using the cin fail to check the validity. If the coding notice having the invalid inputs, so the coding will prompt the user to re-enter the values again, so to ensuring the correctness of the data. Okay, the input are used to calculate the derived Reynolds number, friction factors, and entry lengths from the theoretical background. Okay, then the next one is the input for program. Okay, we require the 5 type of input require user to enter, which is the pipe parameters like diameters and the width and the length. The next is the input for pipe material. We let the user to choose whether one in steel or in plastic materials, and many more. The third is the input for bands. The user can choose what type of bending he wants, such as like 90-degree bending and how many bending in which orientations, like horizontal and like vertical downwards and upwards directions. And all the characteristics from here, user can choose it. And the next is the input for ball valves. Okay, user also can choose what type of valves you want to use, which means like half close or one of the 4 half close of the gate valves that user can be choose from the piping simulator analysis. The next is the output. Okay, so after the user enters the required data, the system will command and execute it to clear all the input data displayed on the terminal. Subsequently, all outputs are set to text file and display on the console along with their corresponding units. Okay, finally the file is closing using the required file names.
Now, we'll discuss on our result. In our project, we decided to make 10 cases of different pipe design. As you can see on the screen, there's 10 types of pipe design. So here are the details on our pipe design. First, for the shape, we have 3 types, which is circular, square, and rectangle. Here are the geometry for the shape, which is diameter for circular, height and width for square and rectangle. Furthermore, we also included gate valve, with a total of 4 gate valves are included, which is fully open, 1/4 closed, 1/2 closed, and 3/4 closed gate valve. Next, for density and velocity of fluid, we make it constant for all cases. Same goes to dynamic viscosity. Alright, for the type of material, we have 6 types, which is glass, plastic, cast iron, galvanized iron, stainless steel, and commercial steel. In fluid mechanics textbook, we can find the different surface roughness for each type of material. Therefore, we decided to use these 6 types of material. This shows the band design in our 10 cases. In our project, we included a maximum of 3 bands and a minimum of 1 band in every case. So, for the type of band, we consider 4 types of band, which is 90-degree smooth band, flange, and threaded, 90-degree melted band, without wings, and with wings. For orientation, we consider horizontal, vertical upwards, and vertical downwards. Next, this is the output of the value by using Excel and C++. Here now, look at the percentage error of different cases between Excel and coding. As you can see, most of the percentage error has less than 10% percentage error, except for case 5 and case 10. Why case 5 and case 10 has more than 10% error? This is the reason. Let me show you. So let us look at case 10. So in Excel, the minor loss of case 10 is similar to minor loss of case 10. But the major loss has a big difference between Excel and C++. This is due to the reason that major loss is directly proportional to friction factor. In C++, we use Hallan equation to code the friction factor, but in Excel, we use explicit Churchill equation to describe the friction factor. This is because in Excel, explicit Churchill equation will be more friendly to the user. So the difference in major losses has causes the percentage error.
So in this discussion part, we have developed the core principles of internal flow in C++. We have 6 circular pipes, 2 rectangular and 2 square duct, which are 10 cases. Diameters remain consistent along the pipe, and saturated water density remains at 997 kilograms per meter cube in all calculations. And fluid velocity is fixed to 0.8 meters per second to test for turbulent flow. And in order to ensuring accurate calculations, for saturated water, we use a density of 997 kilograms per meter cube and a dynamic viscosity of this number. And we provided tables here. For example, if the temperature is 25 degrees, our saturated liquid water, the density is here. And then In bends, we limit our finding to 3 bends to prevent a long table and calculations. Program can execute the number of bends as desired by the user, and there are 4 types of bend used in this program, which are 90 degrees smooth bend, flange and threaded, 90% middle bend with and without bends. And these are loss coefficients. 90% smooth bend flange gives a value of loss of coefficients of 0.3, 90% smooth bend threaded is 0.9, and so on. And the table is provided here also. The length of pipe after each bend is required to be input by the user with an orientation of horizontal, vertical upwards and vertical downwards. To clear the confusion on the orientation of the pipe, this program is meant to be in 3D mode, where the horizontal axis is on the x-plane and the vertical part is on the y-axis. For instance, when a user inputs a bend, but the pipe orientation is horizontal, the pipe goes to the z-axis instead of y-axis. However, when the user inputs a bend and the pipe is oriented vertically, the pipe goes onto the y-axis direction, either positive upwards or negative downwards. Outputs are hydraulic diameter, which depends on the pipe duct shape or diameter, and cross-sectional area is also depends on the shape of the pipe. And Reynolds number depends on density, velocity, hydraulic diameter, and dynamic viscosities. And there are directly proportional relationship between Reynolds number and density, velocity, and hydraulic diameter, and vice versa for dynamic viscosity. Reynolds number less than 2,300 are considered laminar, and greater than this number are turbulent. And the equation for flow rate is like flow rate rises with both velocity and area. Surface roughness is determined by pipe material, for example, glass and plastic are 0. And in turbulent flow, the friction factor relates to Reynolds number and the ratio of surface roughness to hydraulic diameter, with higher surface roughness causing greater friction losses. Minor losses are related to the total loss coefficient due to bends and fluid velocity. Therefore, as the number of bends and fluid velocity increase, the minor loss value also rises.
Good day, doctor. Today I'm going to talk about the coding part in my tape. So for information, I'm not going to talk about the logic of this coding because I believe that my team has already explained it to you, doctor, before that. So my main priority is just to explain the skills that I learned before in my class and then how I implement them inside this coding. So first of all, let me introduce you the libraries that I included in this coding first. First of all, it is the IO script, which controls the input and then the output of the coding. For the second one is the CMath, which allows me to use the relative functions inside the CMath library to complete the complex calculations in this calculator. So how about the third one? The third one is the limit library that I haven't learned it before, but I learned it by myself. And then the limit is to know the limit of the Cin. For example, I want to make sure that all of the input by the user is in the correct form. So if I want the user to enter the length of the pipe, and then I already set the variable that store the length of the pipe in the data type of the double. As you know, the double is the numeric data type, and then if the user enter the alphabet, which is not the data type, the Cin will occur error. And then in order to clear the status of the Cin, I need to know the limit storage of the Cin and then to clear off the invalid inputs. So like this, the Cin will exit the error status and then can be used again. Then how about the fourth one? The fourth one is the IO minute, which I can set the precision of my answer to the desired decimal places. So this is all of the libraries. And then for the structure of the coding, I have used the control statement, the user defined function, the class, and even the array. And for all of the variables inside this coding, all are made in the array form, or even the calculation also made in the array form. So for the class, I have made 3 classes, which are the circular, the square, and then the rectangular, which are the type of the pipe. So as you know, in the private, I already set off the variables in the array form, and then in the public, I use all of the user-defined function skills to define the function of myself. And inside the functions, I also use a lot of the control statements. For example, the switch break statement, the for loop, while loop, do while loop, and even the if, elif statement like this. So as you can see here. And then inside the main functions, I also got included all of the control statements, as you can see in my report. Thank you.
In conclusion, in the summary, the C++ programming language is used to create a program that determines all the parameters needed for flip flow pipes analysis given various input variables. After that, the outcome will construct with calculation made by Microsoft Excel. When the total head needed for each cases is compared in this instance, 35.969214% is the highest percentage error that is found. This fact that the percentage error cannot be negligible and disregarded leads us to the conclusion and that our results are not very accurate. Nevertheless, our program has certain limitations that have been further addressed in the discussion session. And the last is our reference. There are several references in the show by the slide.